Hello and welcome to this exciting video. Here we're looking at this is a topic under physical quantities, and here the physical quantity that we're trying to talk about here is actually time. Okay, we are trying to talk about time. Okay, so now under time there is one instrument that we always study. Remember, time is measured in what? Seconds. These are the SI units for time. It's measured in seconds, and here we are looking at this simple pendulum, which is an instrument that can be used to measure actually time. Okay, so we're going to look at, so this is the structure of a simple pendulum. It's just made up of a string, okay, with a bob on top. Okay, so this one is called the bob. Okay, and this one is just a string where it hangs. Okay, this is not something even fancy. It's just a bob, more like just a bow, and then you tie it to a string. So just like this, they tie it to a string. So now what happens is that what you are seeing here is this same string and bob. So here, if you move it this side, okay, move it this side at this point. So if you bring it this side, let's say you bring it this side, so the bob is here. Now we are going to call this one as point A. Okay, then here where the bob was, we can call this as point B, and then here where the bob will go is point C. So here, let's say you were holding this with your hand, and then immediately you let go, this bob will start swimming. It will start swinging like this. It will swing to the point where it was. It will swing all the way, and then it will swing back again. Okay, it will swing back, and then it will swing back. So now it can take as many swings as it can take. Okay, so that's how a simple pendulum works. So it's just this string. Okay, so most of the times they appear like this. You think maybe there's a string, another string. It's just one string, but then once you move it this side and then you let go, it will begin to swing just like this. Okay, so it is called a simple pendulum. So there are a number of interesting things here that we can talk about. Okay, so for example, we have what we call the period. Okay, the period. So the period under this pendulum, it is denoted by the symbol T, and it is measured in seconds as well. So what is the period? So now the period is actually the time it takes to make a complete swing. Okay, the time taken. So we're going to say time taken for a complete swing. Okay, for a complete swing. So now what is a complete swing? Okay, what is a complete swing? So a complete swing is when the bob swings from A to B to C and back to A. Okay, so this complete swing, sometimes we say a complete what? Oscillation. Let me just write that somewhere. Complete oscillation. Okay, a complete oscillation. Okay, so these words shouldn't confuse you. An oscillation is just a swing, when it swings like this. So what we call a complete swing is when it swings from A to B to C and back to A to A. Okay, so A to B to C, back to A. So now the time it takes, it's called the period. Okay, and it is given by this formula. We say period is equal to the time it takes over n. Now what is n? Okay, so the small t there is the time that it will take. Okay, so we're going to say time taken, and then n is the what? Is the number of oscillations. So don't get confused when we say oscillations. We are talking about the number of what? The number of swings. That's what we call oscillations. Okay, number of oscillations. So this is what you have to know. So this is the formula that you need to know. Then there's another thing now that you have to talk about. It is called the frequency. The frequency. Now the frequency, it is measured in hertz, capital H. So usually we write Hz. Okay, for hertz we say Hz, hertz. And this formula for frequency is actually F is equal to T. F is equal to 1 over the period. Okay, 1 over the period. So these, you find that these are the two most important formulas that you really need to know under this topic. Okay, so I hope you've learned something here. Let's do an example. You see how questions can come under the simple pendulum. The diagram shows a pendulum oscillating between position A and C. It takes 3 seconds to go from A to C and back to B. What is its period? So what we are saying is this bulb moved like this, it went all the way, and then it came back here from A to C and back to B, but it never went there again. What is its period? So we said period is equal to T over N. So we're told it takes 3 seconds. That's the time it takes. So we're going to say the time is 3 seconds. Now, what will be the number of oscillations? So the number of oscillations is the number of swings. So we count this one as so from A to B, this is a quarter. Okay, this is a quarter. So we say this is 1 over 4. From to B, B to C is another quarter. Now 2 quarters will make half. Okay, sorry, 2 quarters together will give you half. Okay, so if this is a quarter again, also this is a quarter again. So you can say A to B to C and back to B. This was actually 3 quarters. Okay, 3 over 4. So you just count here 1, here 2, coming back 3. So that's how you get 3 over 4. Okay, so if it says 1 to B, we'll just say 1 over 4. If it says A to B, B to C, you count 1, 2, so it will be 2 over 4. Okay, so just like that. So N here is actually 3 over 4. So we're going to say 3 over 4. Okay, so when you have such something like this, now what we normally do here, you multiply these two together. 3 by 4, that will give you 12. The denominator is still 3, and you get 4 seconds. Okay, you get 4 seconds here, and that's your fine. So the tricky part here is finding the n. So how did I count? 1, 2, 3. Okay, 3 over the complete, they should be 4. So that's why you say over 4, because it has to go 1, 2, 3, 4, but then it didn't complete, so it went 1, 2, 3, and that's how you find it, 3 over 4. So then here you multiply these two, always multiply this one and this one, give you 12. The denominator 3 into 12, so 4 seconds. So the period here is 4 seconds. Okay, so we have another question here. The diagram shows a pendulum oscillating between positions A to C. So it takes 3 seconds to go from A to C. What is its period? So it moves from A to C like this. So here the number of oscillations will be how many? It moves 1, 2. So this will be 2 over what? The total is what? 4. Then time, it takes 3 seconds. So what is the period? So you are going to say period is equal to time over the number of oscillations. The time, 3 seconds, over 2 over 4. So like I said, you multiply these two, you get 12. The denominator, the one on the mid is the denominator, and you get 6 seconds as your period. How long does it take? How long does it take for 12 complete oscillations? So once you are given the number of oscillations here, it means your n is 12. You don't need to count from here. Your n is 12. So now they want us to find how long it will take. So we know the formula that period is equals to t over n. So the period, we've already calculated it, which is 6 seconds. We said it is 6 seconds. So we have the number of oscillations, so we're finding the time taken. So let's change the subject of the formula. So it's going to be time taken is equals to period times the number of oscillations. So the period here will be 6, one we've calculated here. The number of oscillations, it's 12. Okay, so what is 12 by 6? So this is 72 seconds. Okay, so that is how you can answer questions. Another simple pendulum. Please, for those that need tuitions, please feel free to just inbox this number on WhatsApp. Okay, for those who are maybe outside Zambia, okay, those who are outside Zambia, you can just add, so our country code is +26. Okay, on WhatsApp you can join our online tuition group. Okay, please share the video, subscribe if you're not subscribed, share the video with your friends. Just give us the support so we can continue to provide such lessons for everyone to benefit. 0974626539.